Hello everyone, thanks for checking out my video today on solving fractions. Before we take a look at solving fractions, let's start with just remembering what fractions are, and then we'll do a little simplifying fractions, and from there we'll go on to actually solving equations with fractions in them. Okay, so first of all, first problem here, what fraction of the circle is shaded? I mean, obviously this is not perfect, but it looks very much like this is going to be a quarter. So 1 out of 4 is shaded. Second one, plot 1/5. Again, this is not going to be perfect, but do the best you can. If we were to visualize, maybe this would be like about a half. This would be a fourth. So a fifth might be right about there. Third one. All right, so what is the value of the point below? So again, we're not looking for perfection here. We're just doing our best guess. This would be 1/2 right about here. So a fourth would be right about there. So maybe this point we could say is about 1/5. Again, if you don't say 1/5 though, if you said something close to 1/5, that would be good. It has to be less than 1/4 for sure. So anything in the range of like 0.15 to 0.22 would probably be an acceptable answer for that one. 1/5 being 0.20, so that looks like that would work. And the last one here, how exactly would you explain the fraction of 1/3? Many people talk about money, a dollar. Many people talk about a pizza or a pie chart. Many people talk about a line, a segment. There's many different ways to talk about it, but really you got to come up with some way where you think about how you think about fractions. Okay, I think the easiest way to think about it in my terms would be a pizza. If you had a pizza and you divide it up into 3 equal pieces, they're going to be pretty big pieces, obviously. So if we drew a circle, we'll do the best we could to divide this up into 3 equivalent pieces. That's pretty close, probably. Okay, 1/3 would be one of those 3 pizza pieces. All right, so let's first, before we do any solving, remember how to add and subtract fractions. Remember, when adding or subtracting fractions, we must first get what's called a common denominator. Okay, so the denominator has to be the same for both fractions, otherwise we cannot add them together. This is a nice easy one because 3, if you multiply it by 2, we would get 6. So we could simply multiply this fraction, the right fraction, by 1, but not the actual number 1, by 2/2, because that'll get me 6 in the denominator. So now my expression is 5/6 plus 2/6. We don't have to do anything with that first one. That's it. And then we can combine them. And then finally, we can add like terms here on the numerator to get 7/6. Most people would be fine skipping this step. You can go from here to there. Second one. All right, so we got a common denominator here. We have 6 and we have 15. 6 does not go into 15 evenly, so that's not a good idea. But we want to think of the least number, the smallest number, that both 6 and 15 go into. And that number would be 30. So if we multiply the first fraction by 5/5, the second fraction by 2/2, that would give us 25/30 minus 8/30. And again, this next step here is something we could skip. We get 25 minus 8/30. So then our final answer would be 17/30. So 5/6 minus 4/15 would be 17/30. What if we started adding x's into it? Okay, no problem. It's still the same thing. The common denominator here is what 7 and x plus 3 both would go into evenly, the smallest number. And that number is 7 times x plus 3. So we'll multiply the first fraction by 7/7, and the second one by x plus 3 over x plus 3. we get 21 over 7 times x plus 3 plus x minus 2 times x plus 3 over 7 times x plus 3. And now we can add these together. So it's 21 plus, now we're going to do some distributing here and simplifying. So x times x is x squared, plus 3x minus 2x is plus x minus 6 over 7 times x plus 3. And we can combine some like terms in numerator there to get x squared plus x plus 15 over, and if I distribute the bottom, 7x plus 21. So at this point, I would like you to pause this video, and on the next slide there are 6 problems. I would like you to try problems 1 through 5. Once you have finished problems 1 through 5, come back, unpause this video, and check your work. All right, so here are the work and answers for problems 1 through 5. We'll go through these one at a time. So number 1, common denominator there is 35. Multiply by 7 over 7 and 5 over 5, and add together. Second one, the common denominator here is 3. You can imagine this as like an over 1. So we don't got to multiply the first fraction by anything. Multiply the second fraction by 3 over 3. Number 3, the common denominator here is xy. So multiply the first fraction by y over y, and the second one by x over x. And then just add together. First restrictions on our domain here. X can't be 0 and y can't be 0. So we can't put a 0 in for x or a 0 in for y because we get back an undefined answer. Number 4, multiply the first one by x over x, the second one by x plus 5 over x plus 5. Combine the numerators and simplify. We get 2 numbers that x can't be 0, and x can't be negative 5. Because if it was 0, this would be undefined. If it was negative 5, this would be undefined. And number 5, the last one you were supposed to try. The common denominator here is x plus 3 times x minus 1. Multiply this by x plus 3 over x plus 3, and this by x minus 1 over x minus 1. And then you just do some algebra to simplify. Make sure you distribute the negative 2 here. That's the big mistake that a lot of students would make. And then combine like terms, and we get 2 restrictions. It can't be negative 3, and it can't be 1 for x. All right, so let's take a look at number 6 together. So the common denominator looks like it's going to be x plus 2 times x squared minus 4, but it's actually not. This we can rewrite to x plus 2, x minus 2, right? So now our common denominator is just x plus 2, x minus 2. So I don't have to multiply this fraction by anything. It already has both, but I do have to multiply this one by x minus 2 over x minus 2. So now I get 5 over x squared minus 4 plus x minus 3 times x minus 2 over x plus 2, x minus 2. Do some simplifying here. We get 5 plus x squared minus 3x minus 2x, so minus 5x, plus 6 over x squared minus 4. This would also be x squared minus 4. Write your answer in descending order here and combine like terms. We would get that. On our last slide, we're going to do some solving now. All right. So to solve, we still want to get a common denominator. The common denominator here, remember this is over 1. The common denominator is the smallest number that both 6 and 5 and 1 can all get into evenly. That would be 30. So multiply this one by 5 over 5, this one by 6 over 6, this one by 30 over 30, and we would get 10x plus 25 plus 6x minus 6 all over 30 equals 120 over 30. All right, then our next step is going to be to multiply both sides by 30, so we're left with just the numerators. Simplifying would give you 16x plus 19 equals 120. Subtract 19 and divide, we get our answer of 101 over 16. For 8, the common denominator here is x plus 2. So multiply this by x plus 2 over x plus 2. We get 3 minus x minus 2 over x plus 2 equals 7 over x plus 2. Multiply through by x plus 2, and we get negative x plus 1 equals 7. Subtract 1 and divide by negative 1, we would get x equals negative 6. Notice that x definitely could not be negative 2 here. This is x plus 3x minus 3. So our common denominator here is going to be x plus 3x minus 3. Multiply the first one here by x plus 3 over x plus 3. The second one by x minus 3 over x minus 3. I'm left with 8 times x plus 3 plus 2 times x minus 3 all over x squared minus 9 equals 4 over x squared minus 9. Multiply through by the denominator and it's gone, and we're left with 8x plus 24 plus 2x minus 6 equals 4. So then solving, we get x is negative 1.4, or 14 over 10, or 7 over 5. So number 10 and 11 here, we're solving it for x, right? So we're going to get x by itself. So how do we get x by itself? The first step is to subtract by from both sides. And divide everything by a. Number 11. If we found a common denominator here, it'd be xy. So y over y, x over x, and then xy over xy. And we're left with ay minus bx over xy equals xy over xy. Multiply through by denominator, we get here ay minus bx equals xy. All right, so we're still going to solve this for x. So what we want to do is we want to collect all terms with an x in it on one side. So I'm going to add bx to the other side. Then I'm going to factor in x out. And I'm going to divide by y plus b. And we get ay over y plus b equals x. All right, the last one here, we're talking about Joe's test scores have been these three numbers. Find the range of values that he can earn on the next test that will give him a B overall. Okay, so remember, what we're doing here is we're going to do 92 plus 83 plus 86 plus his next test score, which we can call X, over 4. Because there's 4, and that's going to be his average. We want his average to be greater than or equal to 80, but less than 90. Okay, so adding 83 and 86 and 92 together first, combine like terms there. Let's see, we would get 250 plus 11, 261 plus x over 4. Multiply through by 4. And subtract 261. So if he scores, okay, add an equal sign there. If he scores between a 59 inclusive and a 99 exclusive on his next test, he will have a B overall. So it looks like if he scores 100, he would end up with an A overall. Okay, that'll do it for our look today into solving equations that have fractions in them. This unit, we're going to do a lot of solving with different types of equations, so this is a good first step in that process. Thanks as always for checking out the video today, and we'll see you again soon.